Alright, so this video is going to be part 2 of our practice for finding equations for planes, okay? So in this video we'll be finding all 3 equations for the plane that contains the points 0, 0, 0, 2, negative 3, 2, negative 3, 8, and 8, 1, 4, okay? So first, okay, just like in the part 1 video, we need to find 2 vectors that are on this plane. Okay, we can do that pretty easily, okay, because we have this 0, 0, 0 right here, which makes it really, really convenient, okay? So 2 vectors that are on this plane are just going to be 2, negative 3, 8, minus 0, 0, 0. Okay, these are the position vectors for both of these points, okay? And, well, if you subtract that, you get a vector that's on this plane, 2, negative 3, 8. Okay, so this vector is on that plane. You can also do the same thing with 8, 1, 4, and of course when you subtract 0, 0, 0, you get 8, 1, 4. So these are 2 vectors that are on the plane. So if these are 2 vectors that are on the plane, okay, if we find the cross product, we will actually be able to find our normal vector, because our normal vector is going to be orthogonal to both these vectors. And if both these vectors are on the plane, then, well, what's going to be orthogonal to both these vectors? Something that is orthogonal to the plane. Okay? So, now we just need to set up our 3x3 matrix and go ahead with our cross product. IJK, and we have 2, negative 3, 8, and 8, 1, 4. Okay, so now computing our cross product, we get that this is equal to I hat times negative 3 times 4 is negative 12, minus 1 times 8 is going to be 8. We get minus j hat times 2 times 4 is 8, minus 8 times 8 is 64, plus k hat times 2 times 1 is 2, minus 3 times 8, that's actually going to be a negative 24, so we'll have a positive 24, so we get again, that was 2, it'll be plus 24. Alright, so simplifying that, we're going to get a negative 20i hat. This will be a negative 56, so we'll get a plus 56j hat, and then we'll have a plus 26k hat. And that's going to be our normal vector right there. Negative 20, comma 56, comma 26. Okay, right there. That is equal to our normal vector. Okay? Now, real quick, I said in the last video, and I was kind of talking about how we could just take all those negatives out, okay, because it's going to be still a vector that is normal to the plane, okay? We can still do the exact same thing here. We can take out, well, let's see what we can take out here. Can we take out possibly a 4? Well, no, because we have this 26 here. But what we can do is take out a 2. Okay, let's just take out a 2. If we take out a 2, we get negative 10. If we take out a 2 of 56, we get 28, right? 56, 28, yep. And if we take out a 2 from 26, we get 13, all right? And that way, we're not dealing with as big of numbers, okay? I mean, it works out a lot better in some other cases, but you know, here we were only able to divide by 2. Now, what we're able to do this is because, well, that vector, negative 20, 56, 26. Let's say that the plane is the board and that vector is pointing out way towards you, okay? Well, this vector is still going to point towards you, it's just not going to go as far, okay? It's still going to be, it's going to, you know, if this vector goes to about here, okay, well then this vector will go to about here. But it doesn't matter because it's still orthogonal to the plane, so we can still use it. All right, there you go. We got a normal vector. And lastly, I'll just actually erase this because I'm not going to have enough room on the other side of the board here. So what we can do is actually just start finding our equations. So for the vector equation, we need the normal vector dot the vector r minus vector r naught, and that's going to be equal to 0 because these 2 things are orthogonal. We can plug in our normal vector. you have a negative 10, comma 28, comma 13, and we're going to dot that with, well, we have an r minus the, we can just write the position vector for anything here. Let's do, actually we can just do 0, 0, 0. So we just get dot r, and that's going to be equal to 0. Okay, that's just the position vector for one of these 3 points because they're all on the plane, so they'll all work. Okay, we can all plug that in for r naught. Okay, so now we can just compute this dot product, okay? Because right now, this right here is our vector equation. Okay, so if we start computing this dot product, we'll get the scalar equation. Okay, so right here we have a negative 10, comma 28, comma 13. We're dotting that with vector r is the same thing as x, y, z. Just some point that's on the plane. And that's going to equal 0. When we start computing this dot product here, we're going to get, well, you have a negative 10 times x, it's negative 10x. We're going to get plus 28 times y. We get plus 13 times z. Okay, that's going to be equal to 0. Right there, that is our scalar equation. Now, one thing to note here, okay, because we were able to plug in something nice for our r naught vector, which was the vector, the 0 vector basically. This is also our linear equation. Okay, there's nothing to distribute here to clean this up anymore. It's already in its final form. So one quick thing before we end here, okay? The form for our linear equation is ax plus by plus cz plus d equals 0. All right, that's the linear equation for a plane. Now, if we, our a, b, and c, okay, what are they representing? Well, that's our normal vector. Those are the components in our normal vector. Okay, the components in our normal vector, our normal vector is a, comma b, comma c. So if you were just asked to find the linear equation and nothing else, you could actually do that a lot faster than going through all the equations just to get to your linear equation. Okay, our normal vector is, negative 10, 28, 13. And you can see that's where we plugged in a, b, and c here. Okay, so we immediately have negative 10x plus 28y plus 13z plus d equals 0. Okay, we immediately have that. Now what we can do is literally just plug in any one of these points. All right, we can plug in any one of those points and we'll find out what our d is. And the easiest one, that's 0, 0, 0. If we plug that in, we get negative 10 times 0 plus 28 times 0 plus 13 times 0 plus d equals 0, and you get that d equals 0 right there. So you could find the linear equation a lot faster if you don't go through all of this stuff. Okay? And the same is probably true for scalar. If you just know the form, you can put it into that form. Okay? So, that might be the quicker way if you're just asked for one of these equations. But if you're asked for all 3, just start out with your vector equation and progress through to the scalar and then to linear. Okay, so that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space, the explanation video for equations of planes, and the next video in the series. Lastly, if these videos are really helping you, consider supporting me on my Patreon, which I have linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.